Dear students, about wireless mobile communication, we are at second unit, and the second unit is explaining about spread spectrum modulation techniques. Okay, spread spectrum modulation techniques. So, in spread spectrum modulation techniques, we discussed about the pseudo noise. In the last class, we discussed about the pseudo noise, and we discussed about the direct spread spectrum. Okay, we also discussed about the direct sequence spread spectrum. Okay, and now we are going to discuss about the frequency hopping spread spectrum. Okay, the frequency hopping spread spectrum. Okay, so as you know, what is a spread spectrum? Spread spectrum is nothing but it is the signals it is transmitting through the air. Signals are spreading in the air, okay, where through the transmitter it is going from sender to receiver. It is going from sender to receiver. Okay, so the general definition of spread spectrum is about analog or digital data. It is about analog or digital data can be transmitted. Okay, so in the same way, analog signal the is also will be transmitted, right? Spread data over wide bandwidth. So every signals, that is signals are going through the a bandwidth, a set of bandwidth, a same set of bandwidth the signals are transmitting. Okay, and makes jamming and interception harder. Okay, so sometimes what happens, the signals may be jam, the signals may be jam, or it may be the interfere. Okay, interfere, and it is going to be difficult to transfer the signals. Okay, and we are going to discuss about this topic, that is frequency hopping. Frequency hopping spread spectrum. Okay, that is signal broadcast over seemingly random series of frequencies. We are going to see about this. And the direct sequence we already discussed. Directly the signals are transmitting or spreading. Okay, so each bit is represented by multiple bits in transmitted signal. Each bit is represented by multiple bits in transmitted signal. Okay, so chipping code is using in the direct sequence spreading system. Okay, right. Okay, so spread spectrum concept we have seen in the last class. Spread spectrum concept is explaining about input fed into channel encoder. Input, that is the signals are in feeding into the channel encoder. We studied about encoder, decoder, multiplexer, half adder, full adder. Okay, so the signals are encoding to the channel, okay, and produces narrow bandwidth analog signal around central frequency. Okay, so the signals are encoded with the channel, and it is passing through the bandwidth. It is passing through the bandwidth around the central frequency. Some specified frequency it is transmitting. Okay, signal modulated using sequence of digits. Signals modulated using sequence of digits. That signals are modulating and through the sequence of the signals. Okay, so spreading code sequence, spreading the signals are spreading by using some technique, code, okay, in the sequence, and typically generated by pseudo random noise number generator. So when the signals are transmitting through the transmitter in the channel, there is because of some disturbance, for example, this it is rapid with air or uncontrollable some problems in the air. Okay, so there may be chances of pseudo noise. Okay, chances of pseudo random number generator. Okay, there pseudo noise will be generated. So increases bandwidth significantly. Bandwidth will be increased meaningfully, significantly, which is suitable to them. Okay, spread spectrum, it spreads to the spectrum, and receiver uses same frequency to modulate signal, demodulated signal fed into channel decoder. When the signals are transmitting through the transmitter, so it is encoding in the server end, and it is decoded in the uh, receiver end. Okay. So receiver uses same sequence. Receiver after decoding will receive the same sequence to modulate signal, okay, and demodulated signal fed into channel decoder, okay. Channel decoder will receive and decode it, and it will sense. If you see the general diagram of the spread spectrum, it is like this, okay. It is like this, that is input to output. Input data, it is channel encoder. Before transmitting, it is coding by giving some code to the channel data, so that it is modulator, it is transmitting, okay. And spreading code, that is pseudo noise, will be generated when it is transmitting. Some disturbance may also be added to that, okay. Some disturbance also may be added to that. So through the channel, it is going through the channel, and when at the receiver's end, it is demodulator. At the receiver's end, transmitter at the demodulator, it will be demodulating and spread code. Pseudo noise generator, which is generated there, will be minimized here, okay, will be minimized here, and it is transmitting through the channel. It is transmitting through the channel, and at the end, it is decoding. Here it is encoding, and here it is decoding to the original data, which is useful, which is the human purpose. Human is easy to understand, okay. It converts into human understands, and it is sends as output, and it sends as output, okay. So through this, what we can gain is immunity from various noise and multipath distortion. So where the immunity will be increased, and to minimize the noise, okay, when it is going to the multipath, so it is the noise will be minimized, and there is a chances of smooth going of that signals, and including jamming also sometimes happens. Can hide encrypt signals. Sometimes what happens, the signals may be encrypted, okay, may be encrypted. Only receiver who knows spreading code can retrieve signals. See, when a decode or encrypted or anything is applied to the signals in the starting end, so the techniques will be known to only the retriever end, only to the receiver's end, okay. So transmitter, it will be removed, okay. And several users can share same higher bandwidth with little interference, okay. Several channels bandwidth also can share the signals, okay. So the same signals will be transmitted to the different bandwidth, and with a little interference. We studied about what is interfere. Interfere is nothing but when more than one signals are transporting. So because of some noise, some interference will be happen. Okay, that is. And cellular telephones. It is going to use for cellular telephones, code division multiplexing, that is CDM, and it is also going to use for CDMA, that is code division multiplex access. Code division multiplex access. Okay. Pseudo random noise. Pseudo random noise, pseudo random numbers. Okay. Pseudo random numbers. Pseudo noise generated by algorithm using initial seed. So it is going to generated with some giving some technique, giving some mechanism to the signals. Some technique will be given, some algorithm, so that the pseudo noise can be minimized. And deterministic algorithm, it is specified to use to that particular purpose. Not actually random. If algorithms good, results pass reasonable test of randomness. Okay. So if it is a set of instructions. Okay. It is not a specific algorithm maybe, but it is a set of instruction, set of to solve the problems. To solve the problems, it is but results pass reasonable test of randomness. Okay, need to know algorithm and C to predict sequence. So whatever the set of instructions is applied at the initial stage at the further random noise is also will be applied at the ending stage. Okay, so predict in the sequence. Okay, now we are going to our topic, that is frequency hopping spread spectrum. Frequency hopping spread spectrum. Frequency hopping is nothing but, so in a sequence of frequency the signals are processing. Okay, what is that? In a sequence of units the signals are processing. Okay, so the signals are going through the frequency in sequence. Frequency in sequence, that is signal broadcast over seemingly random series of frequencies. Signal broadcast over seemingly random series of frequencies. Receiver hopes between frequencies in synchronize with the transmitter. So the signals will be received at the receiver's end by using the transmitter. Okay, so we can hope the set of frequency signals are processing and will be synchronized at the transmitter end. And jamming on one frequency affects only a few bits. So when it is going to jam, when even you are talking also you can observe the things. Sometimes you may not listen what the others are talking, is it not? So the jamming, it is because of jamming. So jamming on one frequency affects only few bits. A set of that instructions may be disturbed. Then afterwards, after some time, the disturbance will be minimized and you can hear the clarity. Okay. Basic operation. So what happens in the basic operation? Typically 2 to the power of k carriers frequencies forming 2 to the power of k channels. So it means the number of total channels are equal to the number of frequencies. Number of channels are is equal to number of carriers. So 2 to the power of k carriers frequencies forming to the 2 to the power of k channels. Okay, and channel spacing corresponds with bandwidth of input. Okay, so what is the channel is having? Channel is corresponding the bandwidth. Okay, which is transmitting is forming in a bandwidth, right? So each channel used for fixed interval. Each channel is using for fixed interval. What is fixed interval? A fixed number of bits have to be transmitted. Fixed number of bits have to be transmitted. That is that 300 megabits per second. It is 300 megabits per second and in IEEE 802.11. Okay, so it is using a mechanism. Okay, a technique is using in networking system, that is IEEE 802. Okay, 0.11. So in that 300 megabits per second signals can be transmitted. Okay, and some number of bits transmitted using some encoding scheme. So some number of bits also are transmitting by using some encoding scheme. So maybe fractions of bit, maybe a part of a fractions of bit. Okay, so sequence dictated by spreading code. That sequence is dictating by spreading codes. What is spreading code? Spreading technique is maintaining the sequence code. Okay, you can see the frequency hopping, the spread spectrum here. See how many channels we have? We have channels of 8. Okay, we have the channels of 8. So each channel is having a fixed set of bits. Okay, so just now we have seen it is channel 1, F1 is having 5 bits, F2 is 8 bits, F3 3 and F4 6 bits, F5 1, F6 7 bits, F7 4 and F8 2 bits. Each frequency channel is transmitting a fixed number of bits. Just now we have seen. So how it is going to work? See, we can say here it is F1 is having the number of bits 5. Here you can see F1 is having the 5 bits here, not here. Here you can see the starting the initial 1, 2, 3, 4, 5, 6, 7, 8. So you can say 1, 2, 3, 4, 5, 6, 7, 8. Is it not? So the starting point is 1, the next one is 2, next one is 3, 4, 5, 6, 7, 8. Okay, so here the value of frequency 1 is 5, that is it is correlating here, it is frequency 1 is at the 5 point. Okay, and you can see F2, here it is F2, the number of bits is 8, so F2 is at the here 8. Okay, F2 frequency channel is frequency the 8 bits. Okay, and F3 is transmitting the signals 3. F3, see this is 3 and this is 1, this is 2, this is 3. Okay, and F4 is 6. Okay, so F4 is 6 bits. F5 is 1. F5 is, okay, 1 bit it is transmitting the frequency channel. Okay, F6 is 7 bits. F6 is 7 bits. So this is place of 1, 2, 3, 4, 5, 6, 7. Okay, at the same time F7 is 4, that is F7 is 4. Okay, and F8 is 2. F8 frequency channel is transmitting 2 bits, that is 2. Okay, and channel assignment and channel use, how the channels are going to be formed. Okay, this is about the frequency hopping. We can see the example, right? How it is going to perform at the transmitter end, at the receiver's end. Okay, you can see the transmitter end, see binary data is executing, binary data is transmitting. What is the binary data? As you know, 0101, see whatever that you are talking, so it will be transmitted, it will be converted into the binary data only. So it is converting into the binary data and it is going to FSK or BPSK. Okay, frequency shift keys, and this is binary frequency shift keys. Okay, binary phasing shift keys. Okay, and the signals are transmitting like this. See here, frequency hopped, this is the frequency hopped, this is our technique, frequency hopping spectrum. Frequency spectrum, this is our technique mechanism, and it is received, and here in this technique we can see some pseudo noise also is coming along with the signals, and it is channel table and frequency synthesizer. Frequency synthesizer, it is going to smooth the signals. Okay, the frequency, and band pass, here it is going to band pass filter, that is about some frequency. It is it is streaming line, you can say it is streamline. It is streaming the signals and it is spread spectrum signal. Okay, it is reaching spread spectrum signal. This is at the end of transmitter level. It is at the end of transmitter level. So it is, we will see at the end of receiver's end. We will see at the end of receiver's end, that is here spread spectrum signal is transmitting to frequency hopping. Okay, so same, it is up to here it is transmitting. Okay, and here band pass filter, about it is streamlining the signals, and it is demodulator. There it was the modulator and here it is demodulator by using the frequency shift keys and binary phase shift keys. Binary phase shift keys. Okay, by this it is again, it is transmitting the binary number to human understanding level. Okay, so we are able to hear that. Okay, slow and fast FHSS. Slow and fast FHSS. Frequency shifted every time seconds. Frequency is shifting every time, that is T control seconds. Okay, and duration of signal element, it is T seconds. So frequency, that is frequency is going through some duration, some period time. So duration of signal element is also, it is duration of time seconds. Okay, time second. Slow FHS is greater than, that is T of C is greater than T of S. Okay, So frequency shift keys, it is T of C is greater than T of S. So in fast FHSS, that is T of C is less than T of S. Okay. So duration is higher, or here it is frequency is shifted. Okay. Slow it is TC is greater than TS, and fast TS is greater than TC. Okay. So generally fast FHSS gives improved performance in noise. So generally what happens? This fast FHSS, that is TC is less than TS, is going to give a clarity signals. Okay. You also can see here slow frequency hope spread. Okay. Slow frequency hope spread. See, this diagram is not for not at all confusing you. It is very easy to understand. See here, message frequency shift keys. Message frequency shift keys. The noise, the signals it is transmitting is going to this here 010101. Is it not? So it is by considering 3 bits, by considering 1, 2, 3, 3 bits, and it is converting into 0, 1. Okay, and it is converting into 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 1. So it will be not like always it will be 0, 1, 1, 1. No, it may be 0, 0 or 0, 1 or 1, 1 or 1, 0, like anything. Okay, that set of frequency it is converting according to the output of the signals, is it not? When transmitters it is transmitting. Okay, so the signals is converting into, it may be 0, 0, 0, 1 or 1, 0 or 1, 1. Okay. Okay, so this is 0, 1, 1. It is defining like this here, and this by combining these 4 bits 0, 1, 1, 1, again it is going to convert into 2 bits. See, by adding these 4 bits, it is converting into 2 bits 0, 0. Okay, here by converting this 0, 0, 1, 1 is going to 1, 1. So it depends on the technique. What is the signal it is using? It depends on the technique. So it may be again 0, 0 or 1, 1 or maybe anything. Okay. So it is streamlining the signals. In other words, you can say it is streamlining the signals, where you can see that it is the exact signals. See, it is highlighting. It is like it is the perfect signals it is transmitting. Okay. So here it is combining T, and here it is also combining the time slot, and here it is combining the duration. Okay, duration of the signals. Okay, and this is about the fast frequency hope signal. This is just now we have seen the slow frequency, and this is the fast frequency hope spread. Okay, so here also the same, the title only the change. Okay, but the remaining is same. By it is highlighting means it is recording a different slots, different the signals. It is recording the different signals. Okay, you can see here it is highlighting. So here it is giving the binary information about 0, 1, 1, 0, 1, 1. Okay, so like that here it is m is equal to 4 and k is equal to 2. Okay, so FHSS performance considerations. Frequency hopping spectrum, that is performance is considerate about typically large number of frequencies used. Typically a large number of frequencies is used. Okay. So direct sequence spreading, we discussed about direct sequence spreading in the last class. Because these two topics are more related, so again I am going to give some important information about this. So the same it is, each bit represented in by multiple bits using spreading code. Okay, spreading code spreads signals. Direct sequence signal is nothing but it is spreading the signals directly. Okay, and this is the same like just now we have seen for this FHSS, and DSSS also it is using the at the transmitter end, at the receiver's end. Okay, so here also it is converting these 4 bits and is going to give here 1 bit. In the last class, in the last slide we see that 2 bits is going to 3 bits is going to be for 2 bits. Here it is going to 4 bits is going to be for 1 bit. Okay, 0110 is converting into 0 and 1001 is going to convert into 1. Why it is going to convert it into only 1? See, by the technique it is using, it is going to, it is because of the signals is transmitting. It may be 0 or 1 or anything. Okay, so this is time slot is going like this, and it is transmitter end and it is receiver end. Okay, so again this code is converting into human understanding code, that is binary data modulator with some time slots, and this is direct sequence reader spectrum, and here it is using this technique. Okay, and here again it is using to the is transmitting, right? Okay, and here it is the spectrum transmitter, right? And that is the channel end and this is the receiver's end. Spread spectrum signal same it is, just now that the difference is demodulator at the receiver's end and the binary data is transmitting. Okay, so direct sequence spread spectrum is using this binary phasing shift keys. Binary phasing shift keys. Okay, you can see the examples. The signals are transmitting like this. Okay, because air is going like signals is going through the air. Okay, so it is transmitting like this, and when it is transmitting, it is giving some code. Okay, see here they have t data, that is distance of t data it is generating, and this is t of t, and this is the duration, and this is the signals. Okay, you can see A B C D how the signals are transmitting and how the signals are giving some code. Okay, +1 -1 +1 -1, it is the converting our code transmission. Okay, code transmission complements. So if 1 is going to -1 with complement, 0 is also going to 1 is a complement, and 1 is going to 0 as a complement. Okay, again 1 is going to -1 is also a complement of complement. Complement of complement. Okay, so approximate spectrum of DSS signals. Okay, you can see here signal, that is T1 is going to be like spectrum of data signal is frequency. Okay, so it is, and it is going to wide here in the A you can see, and here B you can see that spectrum of pseudo noise is adding to the signals. Spectrum of signals is adding and then pseudo noise. Okay, okay, so and here it is transmitting as 1 by T plus 1 by Tc. Okay, here it is frequency, and here it is 1 by Tc, here it is 1 by T plus 1 by Tc. Okay, code division multiplex access. Okay, CDMA, how it is going to use this FHSS. So multiplexing technique used with spread spectrum. Multiplexing technique is using for spread spectrum. Start with data signal rate D. Okay, data signal rate D is starting. Okay, and it is, see, 10110, the third bit or fourth bit. So it is going to start with maybe third bit or fourth bit, maybe 1 bit or like that. Okay, that is called bit data rate. It is also called as a bit data rate. So break each bit into k chips according to fixed pattern. All the signals are going to as a chips. Okay, dividing into equal chips, and it is going to give k chips, equal k chips according to the fixed pattern. And just now we discussed fixed number of bits. Okay, equally fixed k chips according to fixed pattern. Okay, and user's code. By using the user's code, new channel has chip data rate, that is KD chips per second. Okay, so that is the initial stage, and here it is going to that is transmitting. So here it is new channel has chip data rate, that is KD chips per second. Okay, so for example k is equal to 6, 3 users A, B, C communicating with base receiver R. Okay, we are communicating with base receiver R. See, 6 signals that you can see here, code A, code B, code C. Here it is 1 minus 1 minus 1 1 minus 1 1. So it may be or 1 0 0 or 1 1 or anything like. Okay, so 1 minus 1 minus 1. Again it is going to be complement of this. Complement of this is 1 1 and minus 1 1 minus 1 1 1. Okay, so here also it is code for C. It is 1 1 1 1. Okay, minus 1 1 like this. Okay, a set of signals are transmitting between A, B and C, or the three signals are also communicating with each other. Okay, CDMA example we can see here how the code is transmitting. Here it is code is converting, here it is 0 to converting into 1. Again it is transmitting and again it is 0. Maybe it is 1, it is 0. It is 1, it is 0 like that. Okay, so user A, it is here by converting into like this, it is 1. Okay, so it is by converting it into 1 bit. Okay, it is converting it into 1 bit and 1 and 0 or 1. Okay, so total it is message 1101. What is the value of 1101? It is 158. So 156 14. The value of 110 is 14. Okay, and here the user B is the value is also depends. Okay, so here it is giving the example of this one. In the same way, we also can convert into bits, number of bits here. So you may get a different manner of this. So user A plus B, user E plus C. Okay, so like this. CDMA explanation, that is, consider a communicating with base. Consider A is communicating with base. Base knows A's code. Okay, so base knows what is A code, A's code. Assume communication already synchronized. So that communication is communicating and it is synchronizing. A wants to send A that 1. A wants to send 1. If A wants to send 1, so send chip pattern. If A wants to send 1, how it is going to be like? See, send chip pattern, it is 1 minus 1 minus 1 1 minus 1 1. So this is A code. So A wants to send 0. If A wants to 1, it is the code. If at the same time A wants to send 0, again it is going to convert the complement of this above. Complement of this above. See here 1 minus 1 minus 1 1 minus 1 1 1 minus 1 minus 1 1 1 minus 1. Complement of A's code. Okay, and decoder ignores other sources when using A's code to decode. Okay, so the same decoder ignores the source of A's. Okay, this is going through orthogonal codes. Okay, CDMA for DSS. How he is going to use this CDMA for DSSs? Okay, so n users each using different orthogonal pin. Each is using orthogonal separate orthogonal pin, that is with pseudo noise sequence, and modulate each user's data stream by using it is modulating with binary phasing shift keys and multiply by spreading code of user. It is multiplying with the spreading technique. Okay, you also can see CDMA in a DSS environment. How this is going to transmit? See, distance of t, it is going to transmit. A technique is using, and this technique is also using here. Okay, so through the transmitter, through the tower, it is going, and when it is transmitting through the air, some noise also will be generated, and it is the frequency and the second frequency, third frequency, like that, and it is going towards to the that station tower. So from tower, it is going to streamlining, and it is going to simplify it, and it is transmitting. It is transmitting. Okay, at the same time 7-channel CDMA encoding and decoding. Earlier we have seen the 6th channel. Here we can see the example of 7-channel CDMA encoding and decoding. Here we can see 7 channels. Channels are starting with 0 to 6, is it not? So binary number is also starting with 0, 1, 2, 3, 4. So channels are starting with 0 to 6, and the values are 0 is having 1 and 0, 1, 0, 0, 0, 1. So channel may have any value, that is depends on the the signals. Here it is valuing is 10100001. So how this one is transmitting here, you see, it is dividing like, see, streamlining like this, okay. So by streamlining it and adding this 7 channels, and it is streamlining again, it is composing individual channel. Here it is individual channel waveforms, and is combining, and it is composite signals. Okay, by combining it is simplified like this. It is simplified in a synchronization way, and it is transmitting. So at the receiver's end it is displaying, it is going to receive like this. Okay, it is also in the form of binary code. So before delivery, this binary code is converting into the human understandable language. Okay, so this is about the frequency Hope spectrum. The frequency Hope spectrum we seen, and in the part of that we have seen also DSSS and noise, pseudo noise. Okay, so you go through this study material, and you also study. If you have any doubts, you can mail me so that we can discuss. Okay, thank you.